Okay, so with you tried number one, the goal here is give me a second. All right, so the goal is primarily first, let's get the absolute value by itself. Once we've done that, okay, then we can decide whether or not this is going to be an and inequality or the or inequality, which we haven't really seen yet, but okay, we'll get there. So you have your absolute value, right? This is what you want to emphasize because that's what you're trying to get alone. So you want to start by subtracting 3. And then you can go ahead and bring down your absolute value of 8a plus 10 is going to be less than 22. Okay. Now, what do we know about the inequality? Since it points to the absolute value, then we know what kind of compound inequality should it be. Yeah, we want and, right? We want and, so we're going to create the and sandwich. So we create it as 8a plus 10 will be less than 22 and greater than negative 22. Okay. So if you got up to this point so far, pretty good. Okay. Now the goal is to solve for a, right? You're trying to solve for a out working your way out from the middle. So if I have 8a in the middle, the first thing I ought to do is subtract 10 from all 3 sides, because that's going to allow me to bring down my 8a. That's going to be less than 12, but greater than negative 32. Okay. So then from there, what we can do is divide everything by 8. And we know that the 8's cancel, so we have a in the middle. 12 divided by 8, you can reduce both by 4. So you're going to get 3 over 2. And then negative 32 divided by 8, that's just going to be a negative 4. Okay. Yeah. So then, right, this is one of those opportunities where maybe shifting this around into making it a decimal could help, because then you know where to put it on the number line. So then here we go, number line. Let's graph it. We have 0. We'll call this 1.5. And then we'll call negative 4 over here. Right. So remember, we have 2 parts. The first one where we say a is less than 1.5. Right. So if a is less than 1.5, that's an open circle. And then we want to shade to the left, right, where it's less than 1.5. Second inequality to pay attention to here is that negative 4 is less than a, right? So then that you kind of do a little scratch work off to the side, and you want to flip that around because you know that that isn't really a is greater than negative 4. So then you can create an open circle at negative 4. And since a is greater than, we shade to the right. Okay. So since this was an and a problem, then we are looking for the intersection. And so the intersection happens in the space in between negative 4 and 1.5. Right? And that's where our solution set will exist. So this solution will be negative 4 all the way to 1.5. Since at negative 4 we had an open circle, that represents a parentheses. And then same thing at 1.5. It's a circle, so then we use parentheses. Okay, so that's our interval. That's our solution set. All right, so with number 2, you have to unpack it first, right? There's a lot more happening on the outside of the absolute value that we need to take care of first before we can get it to the position where we want to be in, that we can convert it to a compound. So the first thing here that we want to do is identify that this 2 in the front is like saying that a 2 is being added, right? So what we want to do is first subtract the 2. Okay, so then what we get now is a negative 5 times the absolute value of 10 minus 2m is going to be greater than or equal to negative 30, right? At this point, since you have negative 5 times the absolute value, you want to get rid of that. So you're going to divide both sides by a negative 5. Okay, so now you get the absolute value of 10 minus 2m That comes down because the negative 5s divide each other out. When you divide by a negative, what happens to that inequality? Yeah, it flips, right? So now it's back to being less than, where your distance is going to be less than 6, positive 6, right? So at that last second, by flipping the inequality, now since it's pointing to the absolute value, it becomes an and problem once again, right? So then this is going to be 10 minus 2m is going to stay less than or equal to 6, but greater than or equal to negative 6. Okay, so I'm going to go back up here to the top. Let me rewrite it. Okay, so now we want to solve from the middle, work our way out from the middle. So let's first subtract the 10 from all three sides. We're going to get negative 16 is less than or equal to negative 2m, which is less than or equal to negative 4. Okay. All right. So from there, let's go ahead and divide everything by negative 2. So we can get m by itself. All right. So negative 2's cancel. You can bring down m. Negative 4 divided by negative 2 is a positive 2. And then negative 16 divided by negative 2 is positive 8. But since we divided by negatives, what do we need to do to both of those inequalities? Yeah, they both need to flip. I'm sorry, I didn't flip them. Okay, so now we have these two statements that need to be read, right? So m is going to be greater than or equal to 2, all right? Let's go ahead and put that down on our number line graph. So here's 0, here's 2. Let's put 8 over here. So at 2, that's going to be a closed circle, and we want m to be greater than, right? M greater than, so we shade to the right. Then we have our second statement, which says that m, right? M is, we have 8 is greater than or equal to m, but we can always rewrite it as m is less than or equal to 8. Okay, so then at 8, close circle, and we want less than, right? M is going to be less than. So there's our solution right there. So in between, right? Remember, since it's an and problem, we're looking for the intersection still. Therefore, it's going to be the space in between 2 and 8. Yeah, you do flip the sign. So then our interval will go from bracket 2 to 8, and then bracket once again, because this time we have closed circles, so we get to include the 2 and the 8 as part of our solutions. All right. Any questions regarding the number 2 problem? You tried number 2. All right. So then on your Nearpod, go ahead and give yourself a score. Okay. So example 6 is the absolute value of 3x minus 2 is greater than or equal to 8. So we have a distance that is greater than or equal to 8. So just imagine, right? You tell somebody the closest you can be to me, right, is 8, because I want you further away from that. I want a distance greater than 8, right? So just imagine, right, you're kind of standing somewhere, and then that person cannot get within 8 feet of you on either side. Right? So they need to be further away from that. So think about the graph that would look like. That's more of an or type of situation, right? Where two different graphs are kind of going away from each other. All right, so first thing is identify that, right? This part here, right? Since this inequality is pointing away from absolute value, this tells us that this will become an or compound, all right? So the first one is what we call the original, right, or the OG. So you're just going to take whatever inequality and whatever absolute value is already there. You're just going to bring it down without the absolute value bars. So it's going to become 3x minus 2 is greater than or equal to 8. Okay? Or now you have your second inequality coming next. Does anybody remember what the trick was for the second inequality? What are the two changes that you have to make? Flip and negative, exactly, right? So flip and switch, good. So you still bring down 3x minus 2, but you need to flip the inequality around, and then instead of 8, it's negative 8. Okay, so pretty simple. Just have to remember those two things. All right, so let's go ahead here and solve. First thing is you want to add 2 to both sides. You're going to get 3x is greater than or equal to 10. So when you divide by 3, x has to be greater than or equal to 10 over 3. Okay, those of you who love decimals, that's the same thing as x is greater than 3.33, and the 3 continues to repeat. Okay, and then we have or. Now let's solve the second one. Right, so we add 2 to both sides. 3x will be less than or equal to negative 6. So we divide both sides by 3. X will be less than or equal to negative 2. All right, so now we graph this, okay? And let's go ahead and put that on our number line. All right, so here's 0. We'll call this negative 2. We'll call this 10 over 3, okay? Since this is the same thing as 3.33, okay? So at 3.33, 3 1/3, you're gonna have a closed circle. And because x is greater than, right, reading this down here, x is greater than or equal to 3.33, we want to be to the right. Okay, so we're shading to the right, and then this keeps going forever. At negative 2, I'm going to use green here. At negative 2, we have a closed circle once again, but we want x to be less than or equal to negative 2. So we want less than, therefore we shade to the left. Okay, so we go left here. And so now I have my interval, right? Since I have or, right, do I need to find the intersection? No, we don't, right? Whenever we have or, the intersection is not what we're looking for. We're just trying to see how much of the graph is shaded in, okay? So we're gonna have probably separate intervals, and then we connect them using the union symbol. All right, so remember that this is going all the way out to negative infinity, so my interval can start at negative infinity, right? We're going from left to right, so, sorry, negative infinity till we get to negative 2, and then it stops. So then that's a bracket around negative 2, since we had a closed circle. Parenthesis, always around infinity. There's a gap, but we still have another interval, so then we want a union with the interval that starts on the other side. So then this one starts at 10 over 3, and then it continues to the right until it gets to infinity, and then we have a parenthesis. Okay, so then this right here represents our interval notation for number 6. Any questions on number 6? All right. Let's move on. Let's go to number 7 now. So number 7, let's see what we got here. Hold up. Okay. Here, I'll try to squeeze it in here. Try both. Okay. So you can see number 7 there. We have the absolute value of 3 minus k. 9 times the absolute value of 3 minus k, and then minus 5, and that's greater than or equal to 67. Okay. All right. So what do you think we should do first here? Yeah, let's add the 5, right? So we add 5, move that over to the right side. Now we can say that we have 9 times the absolute value of 3 minus k, which will be greater than or equal to 72. Okay. What do we do now to get rid of the 9? Divide by 9, right? So let's divide by 9 on both sides. So we have absolute value of 3 minus k, which will be greater than or equal to 8. All right, so very similar. Pay attention now. What is the inequality? What is it going to have us create? An and inequality or an or inequality? Yeah, we want or, right? Why is it or? How do you know that it's an or? Right, it's pointing away. Or you can think about it as the distance is greater, right? Distance is greater than 8, right? Think of the absolute value as distance. So you want distance greater than 8, which means you want to be 8 steps away at least, right? You got to be away from me. All right, so let's split this up, right? We know we have the original, which is just going to stay as 3 minus k greater than or equal to 8. And then you're going to have flip switch, right? That'll be your second one, right? So then you're going to have 3 minus k, but this time it's going to be less than or equal to negative 8. All right. So I'm going to rewrite these over here. 3 minus k, sorry, is greater than or equal to 8, or 3 minus k is less than or equal to negative 8. All right, so let's solve. We got some easy ones here. So let's subtract 3 first. Negative k greater than or equal to 5. So we want to go ahead and divide both sides by negative 1 here, so that we get k will be less than or equal to negative 5. Okay. Or let's solve the other side as well. Subtract 3. Negative k will be less than or equal to negative 11. And then if we divide both sides by negative 1, we'll get k. And since we divided by negative again, now this flips again. K is going to be greater than positive 11. All right. So this one is a little tricky just because on both equations, both inequalities, you had to divide by negatives. So then the inequality flips on both. Okay. So just something to keep track of. Let's plot it on the number line. Here we go. Here's 0. Let's call this 11. Let's call this negative 5. All right. So at negative 5, k is less than or equal to negative 5. So that's a closed circle for us. And then we want to shade over to the right. K is greater than 11. I'm sorry, greater than or equal to 11. So then that's a closed circle as well. And then greater than, you want to shade to the right. Larger numbers are to the right. Okay. Once again, we have the or. Do we need to find the intersection? No, right? We are okay with a graph that looks like this. So let's go ahead and just turn it into the interval notation. This comes from negative infinity. So we have negative infinity to negative 5, parenthesis around infinity, bracket around negative 5, a union. And now we start at 11 with a bracket around it since it's a closed circle all the way till we get to infinity. Okay, so your 3-part answer, you have your algebra, your graph, and then your interval. All right. Questions on number 7. How was that? Better? Satisfying. All right. I'll take it. Okay. Any questions? Are we doing okay so far? All right. I'm going to drop down here to number 8. So you can start writing it down. Let me go full screen here. All right. All right, let's finish up here with number 8, number 9, and then I think we'll call it a day. Okay. All right, so with number 8, right, avoid the trap, right? That's why I keep bringing up this kind of situation over and over, because I want you to learn to avoid that trap where you want to subtract -1 minus 4. Okay, what should we do instead? How do we clean up this inequality? Yeah, let's add the 1 first, right? That's going to help us get rid of it. We add it to the other side as well. So now we're going to be able to have -4 times absolute value of x plus 9 greater than or equal to, that's going to become -20. Okay. And so do you see how the inequality will change at the last second? And then it'll turn our problem from and to or, right? Right now, currently it's sitting like an and problem. But once we clean up and get the absolute value by itself, by dividing by -4, now this and inequality becomes an or inequality. So now we have x plus 9 is going to be greater than 5. All right, so we want our distance to be greater than or equal to 5. And now we know, hey, from here, I just split it up. I create 2 equations, one OG, one switch flip, and then I move on. Okay, so let's do that. So I have x plus 9 greater than or equal to 5. Remember, this is original. And then you have your switch flip scenario, or flip and switch, switch and flip. And then we get x plus 9 is going to be less than or equal to -5. Okay, so flip my inequality and turn my 5 from a positive to a negative, all at the same time. All right, so let's solve. Subtract both sides by 9. So x will be greater than or equal to -4. Okay. Remember that this is now an or problem, so don't forget to bring down the or. Okay, that way you remember or you don't confuse yourself whether you should be looking for an intersection or not. Okay, so it's an or. Subtract 9 again. X will be less than or equal to -14. Okay. So let's finish up here by graphing. There's 0. We'll call this -4. And then -14 a little further down. All right. So for x greater than -4, greater than or equal to -4, we have a closed circle. And we want to shade over to the right. And then for x less than or equal to -14, you also want a closed circle there. And you want to go less than. Okay. So that looks good. Let's go ahead and write down the interval. Okay, somebody help me out with the interval. What should it say? What should it read? All right, so the first half of it should be negative infinity till negative 14, bracket around negative 14, parentheses around infinity. Then I have a gap, right? So now I have a union. And then the other half, yeah, we go from negative 4, bracket around negative 4, all the way till we get to positive infinity. And there we go. Okay, so we have part 1, part 2, and part 3. Okay. All right. Last one, example 9. Okay, let's take a look. Go ahead and write it down. And see, I got a little star next to it. That's a special case. Okay, we got a special case here. So whenever I write down special case, you want to start thinking like conceptually, right? You want to think, okay, distance. Can it be greater than a negative number? When does that happen? Okay, so start kind of thinking about it as you write it down. Okay, so what do you guys think? What do you all think? How could we start the problem? How could we approach it? How should we approach it? Maybe let's start with the inequality sign first, right? That's kind of what we've been using to guide us the entire time. Okay, so we could try writing both or problems. Okay, somebody's saying no solution. Okay, maybe. Let's see. All right, so if at all fails, start by just writing down both inequalities, right? You know that it's an or problem, so let's see if this is even, let's do it. Let's do that. Okay, we can always then find a way to see whether our work was justified later down the road. Okay, so since it's already pointing away from the absolute value and there's nothing else that we need to eliminate from it, okay, let's think about what this is saying. We have 3x minus 4 is greater than negative 2. That's the OG. And then you could also have it as 3x minus 4. Remember to switch and flip. So you're going to switch the inequality and then you're going to flip that number from a negative 2 to a positive 2. Okay, so I'm going to go through the work. And then I'm going to show you how you could have stopped at the very beginning and decided what your solution could have been. All right. So now, if we're working through this, let's add 4. And we're going to get 3x is greater than 2. So if we divide both sides by 3, we have x is greater than 2 over 3. All right. Let's try the other one. Add 4. 3x is going to be less than 6. So when you divide by 3, x is going to be less than 2. All right. So remember, what type of problem was this? And or. It's an or problem, right? Okay, it's or. So when we look at the graph, we're not looking for intersection. We're just trying to see how much of the graph is covered. Okay, what are all the possible solutions? So if this is 0, and we'll call this 2. So 2/3, 2/3 is approximately 0.66, right? So we're going to put that somewhere around here. Okay, so let's graph it. Let's see what happens. So at 2, right, open circle, and you want to be less than that. So you go to the left. At 0.66, right, or at 2/3, open circle, and this time you want to be x is greater than. So now you go to the right. Okay, now you're here. Now typically, right, they do overlap, but does it matter that they overlap? Were we looking for the overlap to begin with? We weren't looking for an overlap to begin with, exactly. So with an or problem, usually we list out how much of the graph is shaded. Okay, so what do you notice? How much of this graph is shaded? Yeah, all of it, right? The whole thing is shaded because we went from 2 to the left of 2, right? So that took care of even the 0.66, right? Because that little part is shaded by the green. And then from 0.66 all the way to the right, right? So then at 2, it took care of 2 because it got shaded in red. So then because it's or, right, we can say that the entire number line is shaded. So we can find a solution anywhere. Any number that we choose will either be less than 2 or it'll be greater than 2/3. So then, right, the interval goes from negative infinity to infinity, or you can say all real numbers. Okay. So now let me take you back to the beginning, and I want to highlight something. And I'm just going to rewrite the problem real quick, right? So we have the absolute value of 3x minus 4, and we're trying to find out when is this going to be greater than a negative 2. What do we know about absolute value? What kind of outputs does it give us? Positives? Yep. And what's the other scenario? It can either give you a positive, or what's the smallest number that an absolute value can give you? It can give you a 0. Absolute value can't give you negative, but it can give you a 0, right? So you either have a positive number or you have 0. And then in either case, would you say that both of those are true? Yeah, right. Positive number is always greater than negative 2, and 0 is always greater than negative 2. So when the only scenarios are positive number and 0, then in this case, it's always true, right? No matter what number you plug in for x, you're going to get either 0 or you're going to get a positive number. And in either case, because those are true statements, then any number works, right? Any number would work for x. So then it's a special case because sometimes you can think about it conceptually without having to do the math on it. Okay, the math can actually confuse you, because if you don't realize that you're looking for an or problem and then you see this overlap, what do you think the trap answer would have been? Right, the trap answer makes you think, I see the overlap, that must be the solution area, but that's not the only part that's the solution area. The whole number line is a solution area. Okay, so then in this case, right, you could have gone straight to all real numbers, negative infinity to infinity, right? So sometimes the math isn't necessary if you understand what the concept is telling you. Okay? Yes, that's correct. That's correct. Because, right? I'm glad you asked that question. Because what if it would have been this way? Now you're telling me that the distance is less than -2, and you have to think about what's going to come out of that absolute value. What are you going to get? Either a positive or zero, right? And so again, you have your cases. Can a positive be less than -2? That's false. And the other option is zero. And is zero less than -2? That's also false, right? So notice how just by switching around the inequality, I went from I could either have all real numbers when the distance is greater to now I have when the distance is less than a negative. This is never true, right? The one that I've done in blue, this scenario right here, this is actually no solution, right? So you have to be careful about what is the inequality saying and is it even possible, right? If it is possible, right, it's likely that maybe it's all real numbers. Okay. But if it's not possible at all, then no solution. Okay. And we have an example of that up above, right? So there is a special case, and I think it was example number 5, right? So you see the difference there. With number 5, it was absolute value, but less than a negative, right? And so there we solved it. All right, what's your question? How did you solve it differently? Okay, hold on. Let me answer one question that I got here, and then I'll go back in a second. Give me a minute. This is the only way to do it correctly. If you did it another way, okay, you said you did it like example 3. Example 3 is you can't do it like example 3. The reason why example 3 was the way you have to look at the inequality. The inequality in number 3 is pointing to the absolute value. So that's when you can make a sandwich, right? That means that if the absolute value is pointing to the absolute value, I'm sorry, if the inequality points to the absolute value, you make a sandwich because that's an and inequality where you look for the overlap. But on example number 9, the inequality is pointing away from the absolute value, which makes it automatically the or inequality. So if you solved it by sandwiching, you did the wrong step there. You created an and inequality when it should have been an or inequality. Okay. So let me erase this. Okay, so I hope that helps. All right, so if an inequality is pointing away from the absolute value, you create or. You have to split it into 2. If it points towards the absolute value, you can sandwich it and solve it like number 3. Okay. All right, and then I'm going to go back right now to number 5. All right. I'm not sure if you wanted me to go back to 5 or just stay at 9. I wasn't sure what you meant by go back.